Hello everyone, I'm Kritika Tang from 7th semester Bhaskara. Today I'm going to be presenting on the topic of a research paper that is related to deep learning, deep voice real time neural text to speech. So let's dive deep into the insights. So, this paper introduces Deep Voice, a text to speech (TTS) system built entirely from deep neural networks. Deep Voice aims to achieve truly end to end neural system, synthesizing and replacing traditional multi stage pipeline with a simpler and more flexible approach. Let's look into the Deep Voice architecture. First of all, there was sedimentation model. Deep Voice utilizes a novel approach for phoneme boundary detection using contention temporary classification (CTC) losses. This model identifies the start and end points of each phoneme with an audio file. Then next is grapheme to phoneme model. This model converts return text into phonemes using a multi-layer bidirectional encoder-decoder architecture with gated recurrent units (GRUs). It serves as a feedback for words not present in a phoneme dictionary. Phoneme duration and fundamental frequencies. A singular neural network jointly predicts phoneme duration and fundamental frequencies (FO). This model assigns duration to each phoneme and generates a fundamental frequency counter for the unit. Then there is an audio synthesis model. Deep Voice Audio Synthesis Model is a variant of WaveNet, a powerful generative model for raw audio. This model combines the outputs of the other components to synthesize audio at a high sampling rate, producing the final uterant. First is WaveNet variant. Deep Voice utilizes a WaveNet architecture. It requires fewer parameters and trains faster than original. Second is unsampling. Instead of transposed convolution, Deep Voice employs a stack of bidirectional quasi RNN, that is QRNN, layers for unsampling, leading to improved performance and fewer parameters. Real-time inference. Deep Voice achieves real-time inference by optimizing WaveNet interference kernel on both CPU and GPU, resulting in significant speedups and previous implementation. Now let's look at deep voice training and evaluation. Deep voice was trained on intern English speech database containing approximately 20 hours of speech data. This model was evaluated using mean opinion score (MOS) rating, which measures the perceived quality of synthesis speed. Models when we use the ground truth 48 kilohertz model, the mean opinion score was 4.75. When we used a synthesized model of 48 kilohertz again, the mean opinion score was 3.84. When we use the synthesized duration and the FO frequency model, the mean opinion score was 2.00. Let's look at optimizing interference for real-time performance. Deep Voice achieved real-time inference by optimizing WaveNet interference kernels on both CPU and GPU. This optimization involves techniques such as avoiding recomputation, doing cache memory accessing, parallelizing work via multi-threading, and using custom hardware optimized routines for multiplication and convolution. The first is CPU optimization. The CPU implementation utilizes multi-threading, thread pinning, and custom AVX assembly kernels for matrix vector multiplication, resulting in significant speedups. In GPU optimization, the GPU employs resistant RNN technology, where the entire audio generation and processing is performed in single kernel, launching with weights loaded into the register file. Now let's look at Deep Voice, a breakthrough in text to speech synthesis. We have seen that deep voice represents a significant advancement in text to speech analysis, demonstrating the ability to deep learning approaches for all components of high quality text to speech engine. The system's ability to achieve real time interface opens over new possibilities for applications such as speech enabled devices, navigation systems, accessibility for virtually impaired. Yeah. So this happens in end-to-end training. The voice can be trained without any human involvement, simplifying the process of creating a TTS model. Real-time performance. The optimized inference kernels enable deep voice to generate audio in real time and make it suitable for various applications. Future direction. Future research directions include merging the different components into single end-to-end trainable system that improves the duration and frequency of models using larger dataset or generative models technology. eVoice, a revolution in speech synthesis. eVoice success in real-time neural text-to-speech synthesis marks a significant milestone in the field of speech synthesis. This big breakthrough has the potential to revolutionize how we interact with technology, making speech-based interfaces more accessible and natural. First is enhanced user experience. Deep Voice enables more natural and engaging interface with devices, improving the user experience. Second is accessibility for all AI. Deep Voice makes speech-based interface accessible to a wider range of users, including those with visual impairment. Third is driving innovation. Deep Voice success paves the way for future advancement in speech synthesis and related technologies. These were the revolutionized thing that deep voice can do. Thank you. These were the insights driven from the Deep Voice Real-Time Neural to Text Speech research paper. This was done under the subject Deep Learning. Link to the research paper has been given here. You can review more. See you in the next video. Thank you.